Hey everybody, today we're going to look at basic collections, lists, tuples, sets, and dictionaries. This is a quick video just to give you a high overview of each of these things, and then you can take a deeper dive into some of the resources I'll list at the bottom. But I will have a longer video going more in depth and showing more some of the different methods you can use for these different collections. So if you want to watch that, check it out. But this is the short version of that, pretty much. So, basic collections, why I say basic is because there are other collection types. There's ordered dictionaries, there's name tuples, there are other types of collections, and I will take some time in the future to go over those. But for now, we're going to stick with lists, tuples, sets, and dictionaries. So, first off, lists, they're a mutable sequence of values. They are a list of whatever you want, pretty much, and the order doesn't really matter. So, they would qualify as like an ordered list because whenever you create a new list, and just as an example, if we go down here and do two, three, 2, 3, 1, and if we printed that list, you see, and in Jupyter Notebooks, you don't have to put the print statement; it'll just return uh, the value. So you can see 2, 3, 1. It keeps the order of that list, so it's an ordered list. And you could see where in Dynamo how important that is. When you have lists, you wouldn't necessarily want them to be automatically ordered without you knowing. And typically, you want to order them yourself, maybe with a node. And that list order is really, really important. So, as you see, lists are ordered. So are tuples and sets, they're not. So, if we did a set real quick, I'll just show you. Um, you can see here, if we did the same exact thing, get the return, we get 1, 2, 3. So I just wanted to point that out. Sets are on no ordered list and tuples are ordered. So if we run this, it'll go through and it'll create a list. So this is the list method, and if we print this, it'll do my list. Uh, it'll print the my list, so we'll get an empty list back. And then this type will just check to see if it is a list. This will check to see if anything's in the list. So if we run this, you'll see that we have an empty list. The class is a list, and the list has nothing in it. Okay, so the next thing is the list of items. So you can put a lot of different things in list. Strings, you can put variables, you can put variables and collections and items and or not items, but strings and integers. I mean, pretty much anything you want, you can put inside of a collection. I mean, we have dictionaries, tuples, sets, uh, and 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 even list. So if we run this, you'll see it successfully ran, and we can just print this list real quick. So if we put this down here, you can kind of see what's going on in there. And so the next thing is list of lists, which you kind of saw already up here because we have a list in this list. But a little bit clearer here, you can see that we have one list, and that's what these brackets kind of stand for. And then we have a list and another list within that overall list. And it could go deeper than that. I mean, you can have list upon list. And if you're familiar with like some of my Dynamo videos, you've probably seen me talk about how important list management is. And the same thing kind of goes for Python as well. So if we run that, you can see we've got a list with a list in it, with another, with a another list, and then a list within that list. So things can get pretty complicated pretty quickly. But just keep in mind how important lists are and list management is. Getting item at index. So we have a list item 1 and 3, and what we can do is take the list, and then we can just put in an index value. So in this case 1, so we should return item 3. Run that, we have item 3. Here we've got list 1, item 2. This will be updating item 1 to be item 2. So if we run this, you can see what we get. Okay, the next thing is tuples. They're a fixed sequence. They're pretty much the same thing as a list. I mean, you can put pretty much anything you want in it. The biggest thing is you can't modify it. There's only like 2 methods, which is like count and index, I think. but there's not a lot of stuff you can do with them. So again, same as the list, you can see we can put practically anything we want inside of them. Here we can check the type and see that it's a tuple. We can have tuples within tuples, just like list. We run that, we can see the output. We can get items at index, so we return item 3 at index 1. And just like we did before, we want to update it. You can see that we get an error because we can't update it. Now, you can convert tuples to list and then update the list. So you can append that value or change that value at the index and then create a tuple again, convert it back. So there are methods to get around that if you ever have to do update a tuple. Okay, sets. And again, tuples and lists are ordered. Sets, on the other hand, are unordered because what they do is when you put in some values, they'll reorder the list. So they don't preserve that order when you create that set. So here's our set. My set equals, and I want to point this out, just like we did before. Like a lot of times, like with list, what you'll see is like list equals brackets. It's just an empty list, and then somebody will loop through something and maybe append to that list. And you can't really do that with sets because it defaults to a dictionary. So you have to go in and say my list equals set, and this will actually create a set type, an actual empty set. So if we do this and then run this, you'll see we've got a set. Our class is set, and is anything in it? No, so it reads out false. Here we have a set of strings. And this is kind of important. So they do. I don't know if I mentioned this, but sets have they collect unique items. So if you've got a bunch of the same items, when you actually see that print that set, it's only going to show the unique values. So set of strings, we see that we have item 1, 2, 3, then 2, 3, 4. So we should only have item 1, 2, 3, and then 4, not the total 6 items that we see here. We should only see 4 when we print this. So I'm going to run this real quick, and you'll see that we've got item 1, 2, 3, and 4. And since I haven't tried this with strings, I want to see what would happen if we type in item 2. I mean, the idea is that hopefully it does order it. So let's see. So if we run that, you can see we've got item 1, 2, 3, 4. So it reorders it, and then it only shows the unique values. Set of nums and strings, so you can add numbers and strings to it, but it is very limited in what you can actually put in the collection. So we have items, we have a number, we have a set. I don't know if we can actually put list in here. So if we type in some or put some list, you can see we get an error. So it is limited in what you can actually put in it. Checking the type, so just real quick, if we check the type, we'll see that that's a set. There are some cool methods you can run on a set, and this is just some of them, and there's a list below with more. But these are some of the things that you can do with sets. So here we have 2 sets, and we're checking the intersection of those 2 sets. You see 2 and 3, they both contain in both sets, so it returns 2 and 3. This checks the difference between S1 to S2, which will have 0, 1. 0, 1 does not exist in S2. And then this does S2 to S1. Negative 1, 4, and 5 doesn't exist in S1. So it returns negative 1, 4, and 5. Union, what that does is it combines them. And so if you've got like 2 sets that are exactly the same, then your output's not really going to have anything different with it. But if it has a variety of different numbers like we do in set 1 and 2, what we're going to do is get, it's going to combine them and order them and only show their unique values. So if we run this, you'll see we start with negative 1, 0, 1, 2, 3, 4, and 5. And just to show you visually, I think this is just a nice way to see it, is we've got this kind of unordered list, and you can see it becomes ordered, or it orders it. And that's what it means by unordered, is that it doesn't preserve the location where it's when you create that set, where that could be incredibly important for you. for lists, or if you're doing things in Dynamo, that might be incredibly important. But in maybe it's not, and you only want to see the unique values, then maybe a set would be a good option. But I want to point that out. Not it reorders it, and you can have some issues if you're reliant on the way that those items are brought into like a specific collection. So dictionaries are my favorite of any collection, and so I really like them. Lists obviously are really important, but dictionaries I find to be really helpful and can extend the application I'm working on by a lot because I can do some really cool things. So, a dictionary is a collection of key value pairs. And so, if we create our dictionary, you can see that it returns a dictionary just like we did before with all the others. We have a whole bunch of different options. The difference is this takes in a key value and returns a value. So there's a key and there's a value in a dictionary. And the key could be unique, it could be an integer or other things. And the value doesn't have to be a string either. You can see here we've got um, numbers, and we can have sets and dictionaries and a lot of different things. So if we run this, we can check the type, and it is a dictionary. And then here we're just returning a value based off of a key. So the key for now that we're using is string. And string is the first one in our dictionary. So it's going to return value 1. So you can see that. And like we could switch this to, okay, we want to see the tuple in that dictionary. We want to see what does that tuple have in it. And you can see if we write that, returns the tuple, and we have the values in there, 1 and 2. So that's a big thing. I mean, we're getting the actual values from it. There's a script that I have that I'll put a video out on that'll actually go through that, but are using a dictionary and how you would kind of push and pull things. But it's very valuable in that script and getting that script to work correctly. So dictionaries are really powerful. I definitely recommend checking them out, learning them, because they can really extend your application. I mean, you could do some really cool things with them. If you just like any of my videos, you can download the video, you can download the documents and everything else with it. So in this Jupyter notebook, you can download it, and there's links to go to the locations where you can read up more about this different stuff. But this is some of the different methods for lists. This is some of the methods for sets, and here's some of the methods for dictionaries. So check this out and let me know. And then also down here, list. It just shows you the different formatting for the different collections. So check those out. But anyways, I appreciate you guys watching. Let me know if you have any questions, and I'll see you in the next video.